Welcome, everyone. I'm very happy that I can be one of the speakers today. We heard some awesome speeches until now, and thank you again for all the speakers who has been just talking today. And special thanks to Hank because he gave a very good introduction to the services I'm going to show you as well, just from another point of view. So thank you again. So yeah, my real topic is how to save more lives with Azure Machine Learning, and my real life scenario is predicting earthquake damages with Azure Machine Learning. In the last few years, artificial intelligence has become more and more prevalent and powerful. And many speeches around AI nowadays explain how these technologies can be benefited to predict stock prices and create value for an organization. And in fact, even the online courses that are meant to educate the new comers in the field are focusing on financial benefits of AI. So in today's materialistic world, I would like to focus on how the very same technologies can be benefited to predict natural disasters and eventually increase survival rates and improve quality of life. Thank you for the intro again. So as you already heard it, I'm Eva Pardi or Eve Pardi. I'm a Microsoft AI MVP and a software developer and data scientist working in full-time at Laerdale. Laerdale is a company which aims to save more lives by providing courses to doctors and nurses all around the world. I'm part of the analytics team where I'm using data coming from these courses to improve these tutorials and courses for our customers. I'm often speaking at different meetups and other community events or conferences. You can also read about my researches and projects at my blog, which I'm going to share with you later on. But you can also find me on LinkedIn, Twitter, and Facebook, and feel free to reach out to me via email if you have any questions or you want to collaborate. What I'm going to talk about today is first, how did we get to the point to use AI for predicting earthquakes and their damages they cause? And then I'm going to show you around the Azure Machine Learning Workspace, but from the visual point of view, not really the coded version like Hank showed us. I'm going to show you how to use notebooks and the designer and the automated machine learning as well. And so you can see all the different assets that you can use inside Azure Machine Learning Workspace. The disasters caused by natural phenomena have been present all along human history, but their consequences are greater each time. So this tendency, won't be reverted in the coming years because it is expected to even increase in the number and intensity due to the global warming. And according to World Statistics, the increase in the number of world disasters between the decades of 1987 to 96 and 1997 to 2006 was 60%, going from 4,200 to 6,800, whereas the number of dead people during these periods increased 100%. It went from more than 600,000 to more than 1.2 million. So, as I said, this tendency won't be reverted, and it is foreseen that natural phenomena will increase in number and intensity due to the global warming. And more than 9 million Australians have been, for example, impacted by a natural disaster or extreme weather event in the past 30 years. And the number of people affected annually is expected to grow as the intensity and in some areas, the frequency of these events continues to grow. And these costs that I am showing you here on this slide, this include significant and often long-term social impacts, including death and injuries, also an impact on employment, education, health, and well-being as well. Humans have been trying to predict earthquake, at least from the 1st century China, when there was this device, a vessel, that had metal dragons facing on each compass direction. And if the ground shook somewhere in the region, the metal ball in the head of these these dragons would drop out, roughly indicating the direction where the earthquake might be. And also in Greece, I can't remember what was the year for this prediction, but they said that animals left the territory when they sort of felt that the ground would shake in that area. And some of these predictions actually sounded reasonable, but after some research, those things were concluded to be natural phenomena with little to no correlation to earthquakes. AI, however, solely relies on data. Generally speaking, the more data, the better in terms of building a reliable algorithm. And many researchers are creating their own applications to predict earthquakes and aftershocks. Also, these systems can monitor aging infrastructure, and these AI systems can also detect deformations in structures, which can be used to reduce the damage caused by collapsing buildings or bridges and all that. So in this talk, you'll see a real-life example of saving more lives with AI, how to examine a natural disaster, and how to use that observation to save more lives. So I would like to start with showing you a story that motivated me to use AI to save more lives. And for this, I prepared this video as well. So in April 2015, there was an earthquake with 7.8 magnitude and an epicenter in the Gork district of Nepal. The disaster killed almost 9,000 people and injured 22,000. And this horror was in most cases caused by the collapsed buildings in the earthquake. Many data scientists have been working hard to improve the survival rate of the next earthquake. Our mission is to build a predictive machine learning model to investigate and understand the risks of damage in case of another natural disaster. The result of our findings is available for mitigation. Which buildings might be strengthening for the next earthquake? It is not only the memorial buildings and homes could be saved, but also. So as I have just mentioned, data scientists. So first of all, what is data science? So data scientists are absolutely obsessed with data. The first thing we always do when we have a problem to solve, that we are looking around for all the possible data sources that we can bring to bear on this problem. So what we have to do then is to figure out how do we acquire this data and how do we get it into some system, and in which system, which can be like a data warehouse, Databricks, or maybe Azure Machine Learning Studio, where you would use this data and maybe prepare it and so on. Because of course, the data is not always arriving in the shape we hoped for, so we might have to spend a lot of time on transformation, cleaning, reshaping, and so on. And then we need to understand the relationships in the data. And what is the data trying to tell us, and which are the features that are important and are useful, and which might just add the noise to our situation. And finally, we are going to do some predictive analytics or modeling, and through that we hope to deliver value back to our customers or end users, which helps them drive decisions and make them even better also. So what we want to do today is to build a predictive model which is able to answer a question by learning from the data we provide, which buildings are in danger when another earthquake comes. So predictive analytics, it deals with designing statistical models or machine learning models that predict. They are calibrated on past data, and then they learn from it to predict the future. So for this, we are going to use something called supervised learning. And we will use Azure Machine Learning Workspace, which is a fully managed cloud service that enables you to easily build, deploy, and share any machine learning solutions. And before we start working there, let me sketch you up the main steps you need to take while working with a predictive model. And I guess this is something not very new for you anymore, but let's get started. So first of all, we will pull in the data into some system, and in our case, that would be Azure Machine Learning Workspace data sets. And we are going to prepare this for training. And it involves data cleaning, like excluding data that gives noise, transformation if we have to do some normalization on the data, maybe some splitting to create training and testing data, And then we are ready to train our model. And as Hank already mentioned, we have this awesome cheat sheet from Microsoft, so you won't really have to fully understand all the mathematics behind these models, because you can get started by choosing a model based on this picture. We are going to take a look at that when we are getting there in the demo. So the next step is scoring, and scoring is also called prediction in our case. This is a process of generating values based on a trained machine learning model. The generic term score is used rather than prediction because the scoring process can generate so many different types of values, like list of recommended items, numeric values, a predicted outcome, and so on, depending on what data you provide and how you train the model and what answer you want to get for your question. And then we have to evaluate our model. Evaluation basically are metrics that tell you how good your model works. For example, the accuracy of a predictive model, that would mean that how well does it predict the future, right? So while working with a predictive model, keep that in mind that it is not always working perfectly for the first try, and that you might have to apply some improvements on your data set, or your algorithms you have to fine-tuned or a bit more. So you have to work a bit more on it so it returns better results in the end, and so on. But the best result is the aim, which is why machine learning itself is also an always improving field. This whole thing might sound a bit like some kind of black magic, but thanks to the tools provided by Azure, you had the chance to easily get started with machine learning and learn about the different algorithms and then understand what the result tells you. The workspace is the top-level resource for Azure Machine Learning, providing a centralized place to work with all the artifacts you create when you use Azure Machine Learning. And this workspace keeps a history of all training runs, including logs, metrics, outputs, and so on. And you use this information to determine which training run produces the best model. You can also deploy your models to Azure Container Instances, Azure Kubernetes Service, to FPGA, and also to an Azure IoT Edge device as a module. And this diagram shows the different components also of the workspace, starting with the user roles that are enable you to share your workspace with other users, the whole team maybe, or share your projects with people. Compute targets are used to run your experiments. And when you create a workspace, associated resources are also created for usage as a storage account, app insights, and so on. Then experiments are training runs that you can use to build your models, and pipelines are reusable workflows for training and retraining your models. Then you can upload your own data sets that you use for experimenting. And you can also deploy your models. Then you would register first, and then they can be reached via the deployment endpoints. You can use different tools to communicate with your workspace. You can use the Azure Machine Learning Studio that I'm going to show you now, or you can use the Python SDK, the R SDK, depending on your preferences, and you can also use the SDK. So before I'm getting into the demo, I just want to tell you that I'm going to share my blog post as well after this session, so you can see all the details that I might not mention in this session. Otherwise, feel free to ask questions during the Q&A. So what I'm going to do now is to move to my Azure portal. And when you want to create a new workspace, you can just go to New and say AI and Machine Learning and choose Machine Learning from here. So what first you have to do is to define a subscription and then choose a resource group where you want to put your workspace to. You define a name for it and you tell them where you want to put it. I might put it to North Europe, and then you choose an edition. So Here I just want to mention that the pricing and features available depending on whether you choose Basic or Enterprise Edition when you're creating your workspace. And you can create it maybe with Basic and then upgrade to Enterprise later, but then that would mean that you would not be able to use some of the features of the workspace. All right, I won't create one now because I have already created this. So when the deployment is done, you can go and visit the resource. And here you can just click on Launch Now, and you would see a place that you have maybe seen before, just in the previous session. And what I want to do first is to understand the data set. So for this, we are going to use the notebooks. And we want to see what are the features that are useful for while building the predictive model. And the aim is to see which values are useful features for us and which are the ones we could leave out because it just gives some noise to the observation. So the Central Bureau of Statistics collected the largest data set by survey, which contains valuable information about numerous properties like area, age, demographic statistics, and more of buildings in Nepal. And the buildings listed in this data set are collapsed in previous earthquakes. And you will be able to download this data set from my GitHub repository. I'll also share with you in that blog post. What we're going to use for experimenting and to understand how our data looks like is this Azure Notebooks, where it might be very familiar for you if you have used the Jupyter Notebook before. You can create some subfolders for yourself. Then you can upload your data here, basically, and then create an IPython notebook that is holding your data. So when we open up this notebook, on the top, we should see, yes, the computation that it is running now. If you don't have a compute, you can just create a new one. And that's going to be used. And that's a good practice to remember to stop this compute because it's quite costly if you forget about it. I keep forgetting it, actually. Anyway, but you can edit the code in line. This is also working pretty nicely, so it's pretty cool. So yes, to read in the data and to create a data frame, I am using the pandas package. That is probably not something new for you. And I'm reading in the data, and then I am displaying the columns and rows that we have. So you can see we have different identifiers, how many floors we have, what is the age of the building, area and height, and all kind of information that might be useful for us. All right, we also have this damage grade column. This is telling us how high is the risk for that specific building of a damage during an earthquake. The 3 means it's a high risk of damage, 2 means it's a medium risk of damage, and 1 would mean low risk of damage. We will continue investigating further the label column. Just first, I wanted to show you that we play now with 260,000 rows and 39 columns altogether. It's really cool that it is telling us this information. This might be useful later. All right, so here you can see the 3 different values in the damage grade column, and also the number of features that are available for each of the labels. The best case would be if these numbers were quite close to each other, though it is very visible that the number 2 has much more examples than the label 1 and 3. This is a big problem because if the model is trained on more examples with label 2, it more often returns the label 2 even when the risk is supposed to be high or low. So we shouldn't train the model on unbalanced data. So we are going to deal with this issue when we start the transformation and preparation of the data before training. And the field of statistics is often misunderstood, but it plays an essential role in our everyday lives. Statistics, if it is done correctly, allows us to extract knowledge from the complex and difficult real world. When we have a set of observations, it is really useful to summarize these features and into a single statement that is called descriptive statistics. And instead of scrolling through and try to understand all your data just by looking at it, we can use some nice Python functions called describe. What we can see here in the first row there is that how many not null values are in the column, as Python's describe function counts only the non-empty fields. And by this information, we can be sure that each of the rows in the observed columns hold not null values. This is also very important, otherwise it gives a lot of noise into any calculation and predictions. Another important observation is at the column starting with the has underscore, that its minimum is 0 and the maximum is 1. And I could assume that these are probably true or false values, but I cannot be very sure about it. But we can make a check on, for example, on this column using the unique function. And then it returns all the unique values in that column that is telling me that it is 1 and 0. So it seems like that I can use this maybe as a categorical column later on. This is also an interesting observation. Another observation you can make here is the minimum and maximum values for each columns. For example, if we look at the age column, we can see the minimum is 0 and the maximum is 995 years. That those ones are probably memorial buildings. And we can also take a look at some graphics here, there, where we can see that we have some buildings. This is the mean here, there, this blue thing. And we can see most of the buildings are really close to the mean. It is between 0 and 200 years. But there's a few buildings that are very aged, it's like close to 1,000. And that's probably this 995 maximum that we have seen in the description there. So yes, so we will have to do something about this, as this is now an outlier values. So we will deal with that later. Also keep that in mind that now we have here 8 rows and 31 columns. Who remembers how many is missing? Is there anyone who remembers how many we had before? So if not, I'm telling you, originally we have 39 columns. But this describe function only shows the numerical columns and the rest is ignored. So that means that some of my columns are holding strings or something that is non-numerical data. And I would take a look at one of these string columns, and I could see that, okay, it has like T, N, and O, and also the count of how many of that value are shown in that column. And we could maybe say that it's also a categorical column, but assigning a numerical category will not be in scope for this session, especially because you cannot be sure that it always have only this many different values when we get a new data set from a customer. So just for your information, inside Notebooks, you can also build the whole pipeline and build a neural network, prepare the data, make the splitting, make the deep neural network, and then do the training and then scoring and evaluation. You can do all these in the Notebooks as well. But from the point where we prepare the data and build the machine learning model, I would like to show it in the designer. So yes, when we prepare for the work with the predictive model, we should already have a good understanding on which features we keep and which ones we leave out. And for now, we can conclude the information we learned with the statistics and some investigations. And keep that in mind that I was showing only examples now. I investigated all the columns before, and I have taken my data set into my experiment. So now you just see the final result of that. So I'm just going back to the main page of the designer, and just want to mention that you can also create a new experiment by just clicking on this one. But I prepared one for you because it takes a while to run this. And for those who has been using this studio, let me do a little heads up here that a few days ago, we got a new design from Microsoft, which is pretty awesome. And we can see the data sets, the modules, and the models in the different menus here. So you can see the data sets that has been uploaded by you and the samples as well. And you can choose your modules from here, even by using a search, or it's pretty well categorized here, so it's easy to find the stuff. And you can also just close it in if you don't need it. And now we don't really need it. So what happens first is that we are pulling in the data, and I do a bit of joining, so my labels and values are connected together. And when I do that, you can also visualize your data set. And yes, and we are still waiting for some design updates on this view as well. I just want to show you the damage grade again, like it is now visualized how the different labels look like. All right, so what we have to think about now is that we have unbalanced values, some non-numerical columns, strings and categorical columns, and some outlier values as well that we have to deal with. So, right, what we want to do first is to select the columns in the dataset where we want to exclude the noisy values. We can just choose to edit the columns and define that, okay, I want to include only the numerical ones. So we simply exclude the ones that are strings. And this is how it looks. You can either choose to include column names, or you can choose to go with all the features, or all the labels, and so on. And you can also add a new rule under it, and then that is defined whether you want to exclude. So you can do it on the other way around as well. But now this is fine. And also we had the has underscore columns, and we said that those are categorical columns. So what I'm going to do now is to choose all the has underscore columns and say that it is a categorical column. That's also a good idea to state here. Another important step of data preparation is something called normalization. That looked funny anyway. So, so the next step is to do normalization, where we exclude outlier values, like we have seen, for example, at the age column. And the goal of normalization also to change the values of numeric columns in the dataset to use a common scale without distorting the differences or losing some information. This is very useful since most of the columns has different metrics with different scale. For example, the ages in years, these areas in square meters, and so on. So I'm going to use a z-score method that is applied on all of the columns except the categorical and the damage grade columns. And then the data would look very funny. I'll just show you. So it would have a common scale, and then they would be like 0 point stuff and minus this and minus that and all that. Interesting, funny numbers, but these are now on common scale and normalized, and now we are ready to work with it. So just quickly, I actually prepared a slide for you, so I can also give you a quick intro. What is z-score and how is it calculated actually? So it makes more sense how those numbers look like that. So z-score uses the mean and the standard deviation for calculating each values, and it takes the value and decreases it with the mean of it, and then divides it with the standard deviation. All right. So the next step. The challenge of working with imbalanced data sets is in most cases, in most machine learning techniques, it's sort of ignored. But if you think about it, they in the end have poor performance because the performance of the minority class is also very important. And in our case, the high risk of damage is a minority class, for example, although that is the most important to identify whether the building has high risk of damage. So I just want to show once again, for just fun, how the data set looks before, how the damage grade looks before. So this is how the data looks like before this normalizing step. And this is how it looks after. See, it is very close to each other now. So what just happened? So one approach would be to addressing the imbalanced data sets to oversimple the minority class. And the simplest approach involves duplicating examples in the minority class, but that wouldn't add any new information to the model. Instead, new examples can be synthesized from the existing examples. This is the approach we used here. This is called synthetic minority oversampling technique, or SMOTE. And I'll show you now how does it work. So what I did, I first started with splitting the data for the one side, where I choose the damage grade where it was 1 and 2. So now the smooth here gets the 1 and 2 damage grade rows. And on the other side, I'm only getting the ones that are higher than 1, so it is 2 and 3. So what the smoothed here does is that comparing these two columns, and based on this parameter given here, it is changing the amount basically. So it is going to create more features of the minority class. So in the end, we are going to have very, very more balanced data. So now finally, we get very close to training. And first of all, we are going to do some splitting here. And we are going to split for training and verification data sets, and with a fraction of 0.7. So 70% will be trained data and 30% will be used to validate our model. And now finally, we got to the point to train our model. First, we need to choose the best fitting algorithm. And as we said, you don't need to fully understand everything about what are these different models and algorithms are providing for you, because I'm going to show you this cheat sheet that is helping you to make your choice. So there are several specific types of supervised learning that are represented within the designer. For example, the classification, regression, and anomaly detection. And when a value is being predicted, for example, car prices next year, that supervised learning is called regression. The approach that anomaly detection takes is to simply learn what normal activity looks like and identify anything that is significantly different. And when the data are being used to predict a category, supervised learning is also called classification. This is the case we need, as we want to predict the damage grade, which, as you already know, has 3 different values or 3 different categories. So when there are only 2 choices, it is called 2-class or binomial classification. And when there are more categories, as we have now, this problem is known as multi-class classification. So we are getting closer. Now we have that we want to predict categories and we want to choose 2 or more categories, and then multi-class classification is our way to go. And now I switch back to the studio. And what I'm going to do is to open this up, and we go to machine learning algorithms. And we can see that is regression, there is the clustering and classification, and it says whether it is multi-class or 2-class only. So we want to choose from the multi-class algorithms. Yes, so when you're not entirely sure which algorithm works better for you, for your specific data set, you can investigate that by pulling in 2 or more algorithms in the same time. But as you can see, I made my choice and I chose to go with the multi-class boosted decision tree, because after some research and investigation, I found that this works best on my specific situation. So what is this boosted decision tree? A decision tree as a predictive model is used to go from observations about an item that are represented in the branches to conclusions about the item's target value that is represented in the leaves. A boosted decision tree is a method in which the second tree corrects the errors of the first tree, and the third tree corrects the errors of the first and the second trees, and so forth. Predictions are based on the entire collection of trees together. That makes the prediction. So generally, when properly configured, boosted decision trees are the easiest methods with which to get the top performance on a wide variety of machine learning tasks. However, they are also very memory-intense learners, so maybe you would have to consider that as well when using it. So let's switch back to the studio. And see, I am using this tuned model hyperparameters instead of a simple train model module, because I prefer saying that I would like my model to use the best parameters, and this tuned hyperparameters is doing that for me, to it's telling me what are the best parameters that should be used for this model to work best on my data. And if you go to the sweep results, it's also telling you that, okay, hell, it's so ugly. Make it a bit different looking. Yeah, there you go. So it is telling you, okay, this is these are the parameters, the different parameters here, and this is the values that you can add to that parameter, and this is the accuracy that it would return. And if you see that this is maybe your best looking return accuracy, that's almost 75%, then you would use these parameters when you training this model. So after training, we are ready to score or do the prediction. This is still on the training and the validation data. So after scoring, we are going to have 4 extra columns where we can see what is the probability of choosing the class 1, class 2, or class 3. And then on the end, you can see what are the labels that are given. And if you want to compare it, you can also take a look at, okay, where is it? The original damage grade for the first one is 2. And the scored one is also 2. So that's pretty cool. But you shouldn't do this, that you're going back and forth and trying to figure out whether it is the same or not. This is where the evaluation can help you out. And in the Classic Studio, we had an awesome, really good looking graphics here, and we're going to get that back at some point. But here you can at least see what is the overall accuracy, the precision, and the recall. So you can have a good idea on how well your machine performs. So this would mean that in 75% of the time, so that means that it's 75% sure about the decision it made. So now, as I said, I am pretty happy with this model, and I'm okay with the accuracy as well. It could be improved, but for now it's okay. So when you think you are fine with the results, you can decide to make a report maybe for your customer, because for example, when I started to work with this project, our customer wanted to have a CSV file as a result. So what we can do is that we get new data from the customer, from Nepal, basically, saying that okay, guys, this is now new buildings that are now standing, and we are not sure whether they are okay or not. So we want you guys to take a look and tell us whether it has high or low risk of damage. So we have to do the same transformation on this data set. Choose the numerical columns only, and then say that, okay, we want to have all of those to be categorical values, and the similar normalization has to be done on it, and then the scoring. And then what I did was just choosing the columns from the result from here. I chose the scored label, so that is, the result that we get. So I just show you as well. So after scoring this data set, we have a scored labels column that is telling for each building what is the risk of damage predicted for that building. And we can see that it is either low or very high risk of damage. So it's very interesting to look into those situations. So what we can do is that from the original data set, I'm taking the building ID and then putting these together. You can also just rename these columns, saying building ID and scored labels, and I want to call it ID and label. And then you can just convert and download to the CSV file and send it to your customer. You don't have to do all this. You can also deploy the model, as Hank already shown you. That is also pretty easy. And then the customer would go there, insert their files, and then get the labels for themselves by that. But instead of showing that, I would rather go a bit into automated machine learning as well, because that's also really interesting. And it's not just that it's interesting. I would say that maybe for learning purposes, it's a good idea to get started with automated machine learning as well. So why is that so interesting? It's because what you can do first is to choose and select some of your data sets that you want to work with. And then you would configure the run. I would say that I would create a new run. And the target column would be, okay, so first of all, this data set won't be enough for you. And I actually had a run prepared for us because I don't have the full data set for this here. I should upload that. But anyway, I just show you how this looks when it's ready to run. So during running, you can monitor how the running looks and how the models perform on the way. And you can see that there are different algorithms that are used and the accuracy of them as well. And you see it's like trying it like different algorithms, like roll of algorithms are tried here. But what we want to do is to choose the best performing algorithm on our data set. So I'm just going to open this up and take a look. This is still not working. Anyway, so it is always cool to see the new design that are provided by Microsoft, because it's now you can choose what are the metrics you want to take a look at. And I first of all would like to take a look at the confusion metrics maybe, because this is my favorite one. So let's see. So what the confusion metrics shows you is that how well your model performs, or another way to say how confused your model is. So it is telling you that, okay, this is the true label, that it is actually 1. Then the predicted label is either 1, 2, or 3, right? So what does that mean? It means that in 1,273 times, it is correctly predicted the label. But it also predicted for a low risk of damage that it is actually high in 25 times. This is more like maybe a problem on the other way around, when the true label is actually high risk of damage and we predict only low. So this can be further improved, but so far we can see it's a quite okay result here. All right. And as Hank already showed you as well, you can see all the output logs and all kind of Python codes that you can use already on your own environment. Because what you can also do is to download this model and make some changes, if you like, on your own environment. And then you can also just deploy from here, basically. Okay. So I just head back to my slide and take a look at whether I forgot something. Right. Yes, because we have talked a lot about pricing and a lot of about this Azure machine learning, how to get started and all that. You are welcome to go and take a look at the Microsoft documentations because they are really well written and these are very detailed. So it's really good to use that to start with. You can take a look at the pricing, how the enterprise and the basic looks like. And feel free to find more about this topic or others on my blog on codewithdev.azurewebsites.net. And now I'm open for questions.
Thanks, Eva. It was very nice session, and very, I mean, good to see that how we can actually leverage these new technologies into doing something which would really help the humanity as such, like saving lives. Okay, so thanks for this insightful session and your time and your effort which you took. With this, I would again ask, if somebody has any question answers, please feel free to unmute yourself and take it away.
Yes, thank you.
I see complete silence here. So
Yes.
yeah,
Yeah, it's late, I guess, for you.
yeah, right. Still, let's wait for a few seconds. Okay, if anybody has any question, I'll be checking the chat window. Okay, you are getting some compliments. Yes, you might want to unmute yourself just to give the compliment directly.
Hey Eva, this is Yash. So I was
Hi.
thinking that you might be getting questions, so that's why I was on mute. But it was a very compact session. I totally loved it in the entirety. And if you have a video or a blog around this, then can you share the link so that we can go ahead and try to get our hands wet around this one?
Yes, I'm going to have a video and a blog post about this as well, either today or tomorrow. I'm going to spend the weekend on putting together the final version because, as I mentioned before, Microsoft also keeps improving not just the design but the possibilities on this platform. So I also keep updating the session. so the latest updated version will be available sometimes in the weekend.
Okay, thank you so much. Thank you so much.
You're welcome. Oh, and
Thank
of course, I'm going to share it somewhere. We will consult with the organizers, and then we can share it
Yeah,
Oh,
so
sure.
you can reach it.
Sure. Yeah, there is a one question in the chat window. I would like to ask on behalf of Ashirwad. Can we upload a custom model which we have made in our system and use it in serverless app?
Yes, it is in like similar ways, like Hank showed you. I don't know if you have seen the previous session. That is also one way to do that. Or you can just you can, for example, there are like different ways of doing that. You can go and do it in the designer because you can simply add your own models as well that you can generate here and then pull that in and use it for your experiment. Or you can also just create a Python code and create your own Python model here. So you have a lot of different ways of doing this. It is really depending on your situation. So what is the exact model look like? How do you want it to work? Whether you want to put into this or to a notebook maybe. So it is all depends on your needs.